Hi, I am Mrityunjay Kumar. Today I am going to discuss one questions from heat exchanger of heat transfer topic, and this question is prepared by myself. And first of all, I will solve the questions, and I will also discuss the concept while solving this question. And at the end I will show you that how many concept I asked in this question, and any examiner can form different types of questions from these questions. So stay tuned till the end. First of all, the question is this: in a counterflow heat exchanger, the mass flow rate of hot and cold fluid, this one is for hot and cold fluid, is 2 kg per second and 3 kg per second. Mass flow given data. Okay. M dot H for hot fluid is 2 kg per second, and cold fluid M dot C for cold fluid, that is 3 kg per second. Next one, a specific heat. Specific heat means CP of hot fluid and cold fluid, 0.75 and 0.5. H for hot fluid is that 0.75 kilojoule per kg Kelvin, and C for cold fluid, that is 0.5 kilojoule per kg Kelvin. Next one, the inlet temperature of hot fluid and cold fluid are 120 and 50 degrees Celsius. So hot fluid inlet, THI for inlet for hot fluid is 120 degrees Celsius, and for cold fluid TCI for inlet is 50 degrees Celsius. Now the NTU value for the heat exchanger is 0.5. NTU equal to 0.5. Now determine, he is asking that the LMTD of the heat exchanger, if it is parallel flow type. Okay, see here, the given data is given for the counter flow heat exchanger. All this data is given for counter flow type, but he is asking LMTD for parallel flow. Asking to determine LMTD for parallel flow. Okay, so be careful at this point. Okay, I will solve this question. Yeah, the question is that for LMTD, if the heat exchanger is of counter flow type or parallel flow type, if he is asking for LMTD, then we need all the four temperatures. Okay, inlet temperatures of hot fluid, inlet temperatures of cold fluid, and exit temperature of hot fluid, exit temperature of cold fluid. But in these questions only two temperatures are given, so I need these two. And here you can see that he is given only two temperatures, means we have to find out other two temperatures. If two temperatures are given, then to determine other two temperatures we have to apply effectiveness of the heat exchanger. But in this question effectiveness value is not given, but one point is given. My friend, one point is given, NTU value is given. From this NTU value we can find out the effectiveness, and from effectiveness we will get other two temperatures and we can determine LMTD. Okay, so I am doing like this. So NTU is given. Okay, NTU is given. So first of all I will calculate the capacity rate. The capacity rate of hot fluid that is m dot h cph. Here m dot h2 into cph 0.75, that value is 1.5 kilojoule per Kelvin second. kg cancel out. Next, capacity, rate of cold fluid. Capacity or rate of cold fluid, that is m dot c cpc. That value is 3 into cpc 0.5. This will also come 1.5 kilojoule per Kelvin second. Okay. Here I have to find out the capacity rate ratio, that is C. Here both the capacities are same. Here both the capacities are same. So C equal to 1. If the C equal to 1 means this is the special case of the heat exchanger. In case of a special case, if I have to find out the effectiveness of counter flow type, then the formula for the effectiveness will be effectiveness of heat exchanger for counter flow type. In case of special case when C equal to 1, then the formula is NTU divided by 1 plus NTU. Am I right? And this one will be NTU value is given 0.5. 0.5 by 1 plus 0.5 means 5 by 50 equal to 0.3. This value. Okay, now I will find out the other temperatures. I can this time. Okay, I am loving this. Okay, NTU value I find that NTU value is effectiveness I got, and that effectiveness was 0.33. Now I am finding other two values. Okay, here I got a C equal to 1, so I can apply any formula for the effectiveness formula. So I am applying, calculating this one, effectiveness of counter flow equal to TCE minus TCI divided by THI minus PCI. Here the effectiveness is 0.33. TCE, I have to find out TCE minus TCI. TCI is 50 divided by THI 120 and this one is 50. When I will calculate this value, then TCE will comes the TCE value will comes 73.1. 73.1 degrees. This one. Now again I can apply this effectiveness formula and I will get the THE value. But this time I am applying other method to calculate the THE value. Now I am applying heat balance equation. Heat balance equation, that is m dot h. What is heat balance equation? First of all, the amount of heat rejected from the hot fluid is equal to the amount of heat gained by the cold fluid. That is heat balance equation. I am assuming that the other effects means there is no losses from the heat exchanger to the outside. So m dot h Cph equal to Thi minus Dhe. This one, this much amount of heat rejected by the hot fluid, and this one equal to m dot c Cpc Tce minus Tci. This much of amount of heat is gained by the cold fluid. Here both the values are same. Now Thi value I have, Thi value 120 minus Dhe equal to Tci calculated, that is 73.1 minus Tc 50. When I will calculate, then this will be Thi equal to 96.9 degrees Celsius. I got all the four values. I got all the four values. When I got all the four values, then I can find out this LMTD value. Okay, LMTD for the parallel flow, not for the counter flow. This is the twist of the question. Okay, so I am finding out now the LMTD value of the heat exchanger if it will be used in parallel flow. So first of all, I am drawing the temperature profile. The temperature profile will be like this. We are assuming this side is the inlet of the heat exchanger and this side is the outlet of the heat exchanger. So this is only the parallel flow, means both the hot fluid and cold fluid direction of the flow will be same for hot and for cold. This side temperature is Thi, that one 120. This side Thi exit 96.9 degrees Celsius. This one Tci equal to 50 degree. This side Tce, that is equal to 73.1 degree Celsius. Okay. Now I have to calculate this difference. This difference is called del Ti, and this side is called del T. Means the difference between hot and cold fluid when both the fluids are enter into the heat exchanger. This one del Ti, and when coming out of the heat exchanger, the temperature difference is del T. Okay. So I am calculating first of all del Ti, then del Ti equal to this one Thi minus Tci, Thi minus Tci, that will be del Ti into Th 120 minus 50, this one equal to 120 minus 50 equal to 70. This value. Now del T. Our del T will be del T equal to 96.9 minus 73.1, that del T equal to, that will be that del T value will comes 23.8. This value. Okay. Now I am applying the LMTD formula. Now I am applying LMTD formula for the parallel flow. Both the for parallel flow and for counter flow, the formula is same. Only that this calculation part is different. LMTD for parallel flow. What is that? Del Ti minus del T divided by ln of del Ti divided by. I am substituting the values. Del Ti for the parallel flow equal to del Ti 70 minus this one, the value 23.8. 23.8 divided by ln of 70 by 23.8. When I will calculate, then this value will comes to 42.82, and I will substitute this value in the calculator and we will calculate, then this will be okay. The question asking this, I got my solution. Okay, as I promised, now I will discuss how many concepts I asked in this question. First concept I asked that NTU, concept of NTU I asked first. Okay, then I asked the concept of effectiveness. Again I asked LMTD calculation. Means in a single question I asked this three. In a single question I covered 3 topics. Okay. Now I am discussing how the examiner can twist this question and how they form different types of questions from this one. Here in these questions I given NTU value is 0.5. What the examiner can do, he will give overall heat coefficient of the heat exchanger. Either he will give overall heat coefficient of the heat exchanger, or he will give HI. Means what HI? That is inlet, inside of the heat coefficient of the heat exchanger and outside of the heat coefficient. Okay, like this they can modify, and there I will got U, and he will give area, heat transfer area of the heat exchanger. Then I have to substitute NTU equal to UA by m dot Cp small. Here Cp, m dot Cp is same for both the fluids, so no issue. But I have to substitute U and A and get the NTU value, and I have to follow the process. This way you can ask. Another way, here counter flow is given, parallel flow is asking, this one is one twist. Again he can ask that instead of LMTD he will ask what will be the heat transfer area if this heat exchanger is used in parallel flow type. Okay. Then at that time I have to calculate Q value, rate of heat transfer. That will be, I will use m dot h Cph Thi, which I used earlier, this one, or m dot c Cpc Tce minus Tci. Any formula I will use, and I will calculate Q value, and Q value I will substitute Q equal to UA LMTD. LMTD I calculated, U will be given in any form, and I will calculate the area of the heat exchanger in case of parallel flow. Okay, that's it from this questions. Hope you guys understand this. Thank you.